Hi everyone, I am using this video to summarize the blood grouping or blood typing and also the blood transfusion. Hopefully this video can help you to prevent your confusion between these two processes. Blood typing or blood grouping is actually the process to find out what is the blood group of the individual. While blood transfusion process is to find out what are the blood that is suitable to be donated to the recipient. Blood typing or blood grouping will always follow the Landsteiner law. In the Landsteiner law, it states that the person with one blood group antigen will not have the corresponding antibody. So to make it simple, it means that as long as you have the antigen, then you will not produce the antibody. On the other hand, the blood transfusion is always follow the golden rules. Golden rules state that we should never give the antigen that is absent in the recipient. So in other words, we should never ever give the antigen that the recipient don't have. So next we will look at how the process is. For the blood grouping, we are taking the blood cell from the individual and mix it with the antibody that is artificially produced. So the concept is, if let's say the antibody that we added to the blood cell will clot with the blood cell from the agglutination, then that means that the blood cell is having the antigen. So if let's say a person is A blood group, so the person will have the A antigen on their surface of the red blood cell. So when we add the anti-A antibody, this antibody will go and bind onto the antigen. It will bind with the antigen, and this will cause the agglutination. But if let's say you add the anti-B antibody to this red blood cell, then this anti-B antibody will not bind to it. For B blood cell, they have B antigen on their surface. So when we add the anti-A antibody, it will not bind to them. So there's no agglutination found. But if let's say we add the anti-B antibody, then the anti-B antibody will bind to this B antigen and cause the agglutination. Well, for the AB blood group, their blood cell will have A antigen and B antigen on the surface. So that means that if you add the anti-B antibody, it will bind to the B antigen. If you add the anti-A antibody, then it will bind to the A antigen. So that means that this type of the blood cell is going to clot, is going to show agglutination no matter with the antibody or the anti-B antibody. Lastly, for O blood group, they don't have any antigen on their surface. So that means that no matter you add the anti-A antibody or you add the anti-B antibody, it will not show any agglutination at all because they don't have the antigen on their surface. So the key purpose of doing the process is actually to identify the antigen that present on the red blood cell. Because by doing this, only then we can know the blood group of the individual. So in comparison, for blood transfusion, we are using the blood cell of the recipient and also antibody in the plasma of the recipient. In fact, the one that's most important is the antibodies in the plasma of the recipient and also the blood cell of the donor. Because when we check, this is the tool that we have to check whether the blood cell from the donor is compatible with the antibody in the plasma of the recipient or not. You have to remember that the blood cell of the recipient and also the antibody in the plasma of the recipient will always occur in the blood circulation in the body of the recipient. And the blood cell from the donor is the one that we can change because this is the blood bag from the blood bank. We can choose either we want to give the AB negative blood or we want to choose to give the O positive blood. So we will choose that. But how we choose that is all based on, well, the compatibility checking. Some of you might ask why the antibody of the donor is not included here. Well, that is because all the blood that is being donated will be washed with the saline. So when it's being washed with the saline, so that means that all the plasma, all the antibody in the plasma from the donor will be washed away. So that will mean that when we are transfusing the blood into the patient, into the recipient, we are mainly transfusing the blood cell. So to check whether the blood cell is compatible for the recipient, so we have to check that. So mainly we will take the plasma of the recipient that contain the antibody and mix it with the blood cell of the donor. So for example, this recipient is containing A antigen and also a positive antigen on their surface of the red blood cell. So this means that this recipient is A positive blood. Yeah, this means that this recipient is A positive blood. Let me write that now. And because the recipient is A positive, so that means that the recipient don't have the B antigen. And if the patient don't have the B antigen, that means that automatically they will produce the anti-B antibody in their body. It is always present, even they are not exposed to the antigen. So can we give this AB negative blood to this recipient? Well, we have to check whether the antigen will react with the antibody in the recipient or not. So never forget the golden rules. Never give the antigen that is absent in the recipient. So when we mix the AB blood cell with the AB negative blood cell with the plasma of the recipient, the A antigen got no problem because the recipient is also having the A antigen, so they won't produce the anti-A antibody. But this blood cell is having a B antigen. B antigen is going to react with the anti-B antibody because it's absent on the red blood cell of the recipient. So they will produce this anti-B antibody. So that will cause the clotting. And this red blood cell is a negative blood, so there's no antigen, the rhesus antigen, the D antigen on the surface. So that's why no problem for that because this recipient is a positive, yeah, so it is having an antigen, so no problem because our rules is never give the antigen that the recipient don't have. And in this case, if you give the AB negative blood to this recipient, this B antigen is going to agglutinate with the anti-B antibody. So this is going to cause a transfusion reaction, and that also means that this blood cannot be transfused. What if we transfuse this O positive blood? This is AB negative, AB negative. This is AB positive, A positive, yeah? So this one cannot be received, yeah? It cannot be donated because it is having this B antigen. How about this O positive blood? This O positive blood don't have the A antigen, don't have the B antigen, and it only have the D antigen that is positive. Can we give this O positive blood to this recipient? Well, first thing first, there's no A or B antigen. So that's why there's no antigen that is going to react with this anti-B antibody. And this positive antigen, the positive D antigen, is also found in the recipient. So that's why we are not introducing the new antigen into the recipient. It is something that already found in the recipient. So in this case, that means that there's no antibody in the plasma of the recipient that will clot this red blood cell. So if there's nothing that can clot the red blood cell, then that means that this red blood cell is good to be donated to the recipient. So the major purpose of this blood transfusion compatibility checking is mainly to identify the suitable blood. And the suitable blood means that it must not react with the antibody in the recipient. Lastly, we will look at the result. For the blood grouping, normally we will collect 3 drops of the blood, or we can also collect 3 tubes of the blood. So after collecting 3 different drops of the blood, then we will add the first drop with the anti-A antibody, the second one with the anti-B antibody, and the third one with the anti-D antibody. This is to identify whether there is presence of the A antigen or not. This is to identify whether there is presence of B antigen on the red blood cell or not. And this is to identify whether there are positive antigen, the D antigen on the surface or not. So for the first result, if let's say the first one is clot, so agglutination, means that this blood cell is containing A antigen, on it. And the second group shows it's no agglutination. No agglutination, which is a negative result. So it means that there is none. There's no B antigen on it. And the third one is showing agglutination, a positive result in the third group. So this means that this blood is a positive blood. So with that, we can conclude that this blood is a positive blood. For the next one, if let's say it is showing all negative result, so it means that there is no A antigen, there's no B antigen, and there's no D antigen. So this will mean that this is the O blood group because it don't have any A or B antigen. And this would be a negative blood because they don't contain any D antigen. So this is a O negative blood. While for blood transfusion, when we mix the blood cell from the donor with the plasma of the recipient, if let's say there is no agglutination, then that means that the blood is compatible. The blood of the donor and also the recipient is compatible. So we can transfuse the blood to the recipient. And this will not cause any transfusion reaction. But if let's say when we mix the blood of the donor with the plasma of the recipient and agglutination occurs, then that means that this blood is not compatible. If let's say we accidentally transfuse this pack of the blood into the recipient, then it is going to cause the transfusion reaction. So with that, that's all that I would like to summarize for this blood typing and the blood transfusion.